For thousands of years, if you wanted to see the planets in our solar system, your only option was to stand in the dark, look up, and guess. Even with the best early tools, we were mostly just squinting through lenses at blurry dots of light in the night sky. Think of our solar system as a giant family tree. We wanted to build a cosmic photo album so we could finally see the actual faces of our planetary neighbors. To fill the pages of that album, scientists had to get creative. They built a fleet of robotic photographers, tough, highly advanced space probes, and launched them directly into the dark. The cameras on these probes evolved remarkably fast. We went from early, heavy machines capturing basic shapes to flying sophisticated modern imaging equipment. As tech progressed, our view changed from counting individual gray pixels to seeing every distinct ridge and crater on a distant world. By sending better cameras into space, we turned distant, abstract dots into vivid, dynamic worlds. Suddenly, we could almost reach out and touch them. Let's start our tour at the center of it all. The sun burns with the energy of 1 trillion nuclear bombs every second. Sometimes hot solar material actually erupts straight out into space. Moving outward, we reach Mercury. To study it, NASA sent the MESSENGER probe, built specifically to survive the intense radiation near the sun. It snapped over 200,000 pictures of huge craters before it finally ran out of fuel and intentionally crashed into the rocky surface. You might expect Mercury to be the hottest planet since it sits closest to the fire. But the next planet in line, Venus, actually holds that record. This diagram shows why. Venus is wrapped in a thick blanket of carbon dioxide gas. This acts like a giant trap for the sun's heat, creating a crushing greenhouse effect that bakes the surface at nearly 900 degrees. To see through those dense clouds, NASA launched the Magellan spacecraft in 1990. Magellan stayed in orbit and used radar to map the entire planet, revealing miles of long lava channels and massive volcanoes. Like MESSENGER before it, Magellan eventually ended its mission by diving straight into the fiery atmosphere. Getting these close-ups often means sacrificing the camera to the extreme environment. Moving one step further out, we find our own home. Looking back at Earth from orbit, you see the only known oasis of life in the entire system, standing out bright against the dark. Then we reach Mars. In the late 1970s, Viking missions gave us our very first stunning looks at its dusty reddish plains and huge polar ice caps. To move past orbital photos, we had to build machines that could survive a 13,000 mile-per-hour entry through the Martian atmosphere and slow down enough to touch the dirt without shattering. Our current surface cameras, like the Curiosity rover, capture 1.8 billion pixel panoramic views. That's enough detail to see individual pebbles while snapping its own high-resolution selfie. By putting wheels on our cameras, we turned Mars into a tangible landscape that we can explore meter by meter, just like a park on Earth. Past Mars, everything gets much bigger. Jupiter is a massive gas planet, dominated by extreme weather, including the Great Red Spot, a storm so large it could swallow the Earth whole. To get a better look, we sent the Juno spacecraft. Juno flew incredibly close to Jupiter to reveal hidden polar regions and violent storm systems. When Juno looked at Jupiter's North Pole, scientists found something completely unexpected. This animation shows the discovery: 8 massive storms swirling around the center. Instead of moving randomly, they are locked into a highly precise, stable geometric pattern. Next is Saturn, famous for its iconic rings. To capture their intricate beauty, we relied on the Cassini spacecraft, using its complex instruments and large dish to send back breathtaking data. Photographing these massive, swirling gas planets requires highly specialized tools. We have to design entirely different strategies to capture their complex weather systems. Pushing even further into the dark and the cold, we reach Uranus and Neptune. These icy outer worlds were primarily photographed by just one extremely bold mission, Voyager 2. And finally, there is Pluto. For decades, it was barely a smudge on our best lenses, until the New Horizons spacecraft flew by in 2015, bringing its icy mountains and plains into crystal clear focus. Capturing that final, distant portrait completed our first pass of the cosmic photo album. It proved that no world in our neighborhood is too far for our cameras to reach. So, what happens next? A new concept called Breakthrough Starshot aims to replace large, heavy spacecraft with a fleet of tiny, wafer-thin probes attached to giant, ultralight sails. By hitting these sails with incredibly powerful lasers from Earth, we could accelerate the probes to millions of miles per hour. At that speed, taking photos of the next star system over becomes something we could actually do in our own lifetimes. We've spent the last few decades turning blurry specks of light into a vibrant gallery of detailed, dynamic worlds. Now, the next chapter of our photo album waits for us beyond our own sun.